welcome to Beginner Oceanography. Today I'm going to be talking about how deep the ocean is and a little bit about how the ocean is divided by depth by oceanographers. So how deep is the ocean? The most common answer you're going to get is 11 kilometers, and that's the depth of Challenger's Deep in the Mariana Trench. But this is only a single point and doesn't accurately represent what any given point in the ocean actually is. If instead you look at an average depth, then it's around 4 kilometers. However, this is biased more towards coastal environments, which have very shallow depths compared to the deep ocean. If instead you look at the mode that is the most common depth in the ocean, then that's around 5 kilometers. And I think that this is the right answer, and I'm going to be talking a bit more about that in this video. Now, how are the oceans divided by depth? They're divided into the categories that are seen on the screen. I'm going to be talking about why they occur at those seemingly random depths, as well as where the ocean actually reaches these depths around the world. I want to start the video with a brief disclaimer. I'm using this software, the mmap toolbox or MATLAB, to make all of the graphs and to count the percentage of total ocean area that I'll be presenting in this video. First thing to note is that according to this projection and this software, the oceans are 66% of the Earth's surface, which if you compare to other sources is a bit short, and this is most likely due to mmap not including marginal seas. For this reason, I'm going to be presenting all of the depths as percentage of total ocean area as standardized by this 66%. The first zone in the ocean is the Euphotic zone, and this literally means well lit in Greek, which makes sense because this is a part of the surface ocean. This is a term that you're commonly going to hear, the Euphotic zone, as opposed to aphotic, which refers to the darker, deeper portion of the water column. The Euphotic zone is defined by the ambient light level, extending from the surface to where the light is 1% that of the surface, which means that the depth is dependent on water clarity and what's in the water at the time. You may hear another term for the Euphotic zone, which would be epipelagic. It means top ocean. It's the exact same thing. It's also defined by light level. One reason to use epipelagic over euphotic is because epipelagic fits in better with the other oceanic zones like Mesopelagic or Bathypelagic. Personally, I prefer Euphotic zone because you're only talking about light levels. One thing to not be confused with is mixed layer depth, which is due to waves mixing and solar heating penetration and a bunch of other physical parameters. This is not the Euphotic zone. The Euphotic zone is only defined by light, and despite the importance of mixed layer depth in determining photosynthesis and other parameters and all of life in this zone, it is not a definition for the Euphotic zone. The standard depths used for the Euphotic zones from the surface to about 200 meters, which occupies around 8% of the total ocean area. These are all localized around continents, so continental shelves, bays, gulfs, that sort of thing. The places shown on this map are also the only places that you'll find relatives of true terrestrial plants like seagrasses or mangroves or other relatives of onshore plants that have adapted to living in the ocean. And this is because this is the only place in the ocean where light from the surface reaches the bottom where plants can live. The next zone in the ocean is the Mesopelagic, which is called Middle Ocean despite it being the second of 5 zones that I'm going to be talking about today. And it's also referred to as the Twilight Zone. The Mesopelagic is defined by light levels similar to the Euphotic zone, with it starting at 1% light at the surface and declining until there's absolutely no light at the bottom. This in reality is between 200 meters and about 1,000 meters in most waters. One interesting fact about this is that despite that there's no light, it actually contains a very thriving ecosystem. The majority of all fish in the ocean live in the Mesopelagic. Now, this isn't because there's a new source of energy in the Mesopelagic. It's still dependent upon the surface. And what happens is there's phytoplankton in the surface, and they sink as marine snow after they die into the deep water, where they are then consumed by zooplankton. This is a very passive way of energy moving from the Euphotic zone down to the Mesopelagic, but the zooplankton can also move up and down throughout the water column, so going up to the surface and then coming back down. And they do this in a pattern called diel migration, where they go up during the day and come down during the night, or vice versa. Fish and larger predators then feed on the zooplankton, allowing for the larger abundance of higher trophic levels in the Mesopelagic. As mentioned before, for the Mesopelagic is from 200 meters to about a kilometer, and it occupies about the same regions as the Euphotic zone, where you're still around the continental boundaries, with a few exceptions. This is about 7% of the total ocean area. The next one is the Bathypelagic, which means deep ocean, and it's fitting because this is really where the ocean is starting to get deep. The pressure is much higher, and most of the food raining down from above that originated in the Euphotic zone has been used up. As a result, you get very long-lived and unusual organisms. So this is where the anglerfish lives, this is where the giant squid lives, and the gulper eel, a bunch of other species as well. But what they do have in common is that they're uniquely adapted to survive when there's very low energy and very infrequent food. These species are very energy conservative. The Bathypelagic has a much larger depth range than the ones we've been talking about. It's from about a kilometer to 3 kilometers, and similarly it occupies a much larger area, being roughly 15% of the total ocean area. If you look at the map, you can see that the seafloor within the Bathypelagic is now located away from the continents. These separated points are the locations of seamounts or undersea mountains, with lines being the location of plateaus or undersea mountain ranges. It is important to note that sea depths within the Bathypelagic are shallow in terms of the deep ocean. So if you look at the mid-Atlantic ridge, for example, it being this shallow all the way down through the center of the Atlantic actually separates the western Atlantic deep water from the eastern Atlantic deep water. And this has large impacts in terms of circulation and the populations that live on either side of the deep Atlantic. The next one is the Abyssal Zone, or as you might hear, Abyssopelagic. It's the same thing, it's just they're combining pelagic so it fits the other naming system. A fact that I find quite amusing is that abyss means bottomless. Despite this zone being called the Abyssal Zone, it's the zone that contains almost all of the sea floor in the ocean. Being so deep, you would expect the Abyssal Zone to have less life than the Bathypelagic. However, while this is true over a larger scale, there are isolated hotspots of diversity within the Abyssal Zone. The key example of this is hydrothermal vents, which vent superheated water mixed with compounds from beneath the Earth's crust, which can be used to form the basis of ecosystems, similar to how sunlight forms the basis for life on the surface. Another major resource for life in the deep ocean is anything that is too large or falls too quickly to be used up by organisms in the water column. Whale falls are a prime example because whales are both very large and very heavy, and so they reach the bottom rather quickly. Because they are so large, whales actually can fuel an ecosystem, a localized ecosystem, for a long time in the deep ocean, up to 50 years, and you might be thinking to yourself, well, okay, but how many whales are actually falling and sinking to the sea floor? There's been a couple of studies that say that it might be every 3 to 10 kilometers in the deep ocean, and so it's not improbable that a larger organism can swim from one whale fall to another and survive for long periods of time off of just whale fall events. I mentioned before that the Abyssal Zone does contain most of the ocean depths, and if you look at a histogram, you can see that, yeah, it's right within the region, the 3 to 6 kilometers that make up the Abyssal Zone. What is interesting, and what I mentioned before, is that both the mean and the median depth are around 4 kilometers, and that this is the number that sticks in people's head, where the actual peak of this graph, the highest frequency, is actually right around 5 kilometers. If you look at the top kilometer of the Abyssal Zone that contains the average depth and is just a little above the median depth, you'll see that it's very clustered around the ocean ridges, and it's about a quarter of the ocean's area. And this is sort of important because a quarter of the ocean, and with the mean depth being the depth that sticks in people's head, you're missing still quite a lot of the ocean compared to the remaining 2 kilometers of Abyssal Zone depth, which occupy the mode, that 5 kilometers I told you, and missing the other 2/3 of Abyssal Zone area. I suppose this is not a problem for more experienced oceanographers, but definitely in my mind it stood out that the coastal regions were so biasing the mean when most of the ocean is around 5 kilometers in depth. Now if you look at a map of the entire Abyssal Zone, you'll see that it does cover almost all of the oceans. That's around 70% of the total ocean area, which is equivalent to roughly half of the Earth's surface. Now I should note that there are estimates that are much higher than the numbers that I presented, up to about 80% of the total ocean area and 60% of the ocean's surface, but I don't think that that dramatically changes the importance of the Abyssal Zone. The last zone is the Hadal Zone, which I'm not going to talk very much about because we don't know very much about it. The name comes from Hades, or the underworld, and is fairly accurate because the Hadal Zone is only describing locations in the deep undersea trenches. If you look at a map, you can see that there's not very many of them in the world. Of particular note, the deepest location in the ocean is Challenger Deep, and that's located in the Marianas Trench. The Hadal Zone is very small, only 0.5% of the total ocean area. And so if you're thinking of the ocean as a whole, it matters much less compared to all the other zones. And so we've talked about all the depths in the ocean. At the surface of the water column, you've got the Euphotic Zone, which gets light from above and is a very thin layer, and fuels most of the productivity in the ocean. Then you have the Mesopelagic, which is just below that, and relies on energy falling from above. Then you have the Bathypelagic, which is rather empty, but again, relies primarily on falling matter from above. You have the Abyssal Zone, which is the sea floor and anything that falls that's large, and hydrothermal vents. And lastly, you have the Hadal Zone, which is the location of the ocean trenches. The most important thing to remember about these ocean zones is that the Euphotic Zone has the most energy because it can absorb it from the sun, and that sort of fuels all of the other ecosystems going all the way down to the Hadal Zone, which has the least energy of all of the zones and the least life. Thank you very much for watching, and I hope to see you again soon.